Hello and good afternoon, everybody. Welcome to the August edition of the Plains and Prairie Potholes webinar. As Rick told you, I'm Dean Granum, the science coordinator, and along with Rick, your host today. We expect the webinar to go, the webinar is scheduled for an hour, and we expect there to be time for questions at the end. And at that time, I'm going to ask you to raise your questions via the phone or possibly on the chat box, and we'll get to them as we can. As Rick has already said, we're recording the webinar, and we expect it to be posted shortly after, a day or two after it's done. And finally, I'll just once again remind everybody to please put your phones on mute so we can really hold down the background noise during the presentation. With that, and without further ado, it's my pleasure to introduce our presenter. Dr. Michael Wimberly is the Senior Scientist in the Geospatial Sciences Center of Excellence and Professor of Natural Resource Management at South Dakota State University. And Dr. Wimberly has published a number of works about land use change in the Corn Belt, and he joins us today to deliver one on the presentation entitled Farm Level Patterns and Drivers of Grassland Loss in the Eastern Dakotas. Mike, thanks for joining us today, and welcome to the webinar.
Yeah, thank you, Dean. I hope everyone can hear me okay. If not, just give a holler, and I'll try to make an adjustment. But I'll just, I'm glad to be here today, glad to be able to share some of this research with you. I think it's interesting. Hopefully you'll find it's interesting. So I'm just going to dive in here. I want to give my acknowledgments at the beginning because this work has been very much a collaborative effort. I've got a number of colleagues from South Dakota State University, a couple of colleagues, David Hennessy and Hong Li Feng from Michigan State University, and then a number of students, Moses Lurie, Nayaz Chowdhury, and Gaurav Arora, who have worked on this project in various ways. Most of these folks are economists, whereas I have a background in ecology, specifically landscape ecology. So this has been a very interesting journey for me working on this project. It's a little different than a lot of the work that I've done before, but I feel I've learned some interesting things from it, and I hope I can share those with you today. So what we're talking about is grassland loss, and this is a dynamic that I suspect a lot of people who are on this call are already aware of. And let me take a step back and give a little bit of background on this. I first got into this topic a number of years ago working with a postdoc of Chris Wright, who was a postdoc of mine at the time. Somewhat ironically, we were actually working on a biofuels project, and we wanted to have a look at some of the implications of corn ethanol expansion for land cover and land use change. So we did a fairly straightforward study using a publicly available data set, the USDA cropland data layer, without going into all the excruciating details. And basically what we found was a lot of land cover and land use change concentrated in the eastern Dakotas. A total of nearly 2 million acres of grassland, defined very broadly, converted into corn and or soy agriculture. And when we factor in changes going in the opposite direction from corn, soy to grass cover, still more than 1.3 million acres of net conversion. And, I would just add that when we did this, we were actually quite conservative way that we process the data. We used some spatial filtering methods to increase our confidence in change detection. And therefore, really, we saw this as kind of a low-end estimate of the amount of change. Other people, working with the same data have found similar dynamics, looking at the data in different ways. A few years later, there was a national level study that came out of the University of Wisconsin, Holly Gibbs' lab, one of her students, Tyler Lark. They mapped more broadly cropland expansion and abandonment across the whole country over a 4-year period, finding more than 7 million acres of conversion to cropland. Of course, a lot of land moving back and forth, but still the net gain of nearly 3 million acres of cropland on a national level. And of course, you can see from looking at that map that cropland expansion is really concentrated in a few places, and one of those is, again, our location here on the western edge of the Corn Belt. And you can look at a variety of different data sets. They all have strengths and limitations, but you see these trends in just a variety of different data sources. We can look at, for example, the county level NASS estimate of harvested acres. And basically, looking at the Dakotas, we've got large increases in combined corn and soy in North Dakota as well as in South Dakota. And basically, if we compare those to what's coming out of wheat and CRP, there's still a pretty big difference. So there's even more grass or more land coming out of other land covers and going into these cropland types. And of course, we're worried about this from an ecological standpoint for a number of reasons. One of the big impacts is, of course, habitat loss and fragmentation. A really wide variety of species are potentially impacted, but particularly amphibians, butterflies, and many different types of bird species are of concern. If you look over on the right, that's some work that we have in progress using Pete Bauman's undisturbed grassland layer combined with some other data set. And that's, just to illustrate that as part of the process of habitat loss, we get habitat fragmentation, where it's getting split up into smaller and more isolated patches of habitat. And then there's, more broadly, there's concern over loss of ecosystem services, including pollination, carbon sequestration, soil protection, preventing erosion, and water quality, nutrient retention. Now, like I said, these land use change studies, although in terms of the specific numbers, they tend to vary. I mean, basically, we get, a consistent story of, large amounts of grassland conversion, grassland loss in the western Corn Belt. But these studies all have limits. Any method that you use for a scientific study has limitations. We know that we have issues with misclassification errors in classified land cover products like that shouldn't be the CRP, that's the CDL, the cropland data layer. Even when we're working with county level estimates from NASS, there's all kinds of sources of errors that come into play. Classification schemes change over time. That's even an issue with other data sources like the agricultural census. One of the big issues that we run into is that we can't distinguish between different types of grasslands. For a variety of reasons, one of the things we'd like to do is understand, okay, if we're looking at native grass versus tame pastures versus CRP, how much of each of these types are we losing and gaining, and where is it happening? The other thing is when we work with these big spatial data sets, it's actually, you look over on the right, we can see quite a bit of detail in terms of the landscape patterns, but it's actually very difficult to point to a pixel or a field in that landscape and actually connect it to the decision-making agent, which in this case would be a landowner or a farm operator. So to try to, as part of this project, supported by USDA and in collaboration with the colleagues I mentioned earlier, we undertook a survey of producers, farm operators in eastern North Dakota and South Dakota to try to bring in, really a different, a new source of information to give us some new insights into what was happening. And if you look on the right, that is the extent of our study region. You can see the circles represent the number of responses we got per county. So we've got 41 counties in South Dakota, 23 in North Dakota, targeting farm operators with at least 100 acres who raised at least some wheat, corn, soy, or grass hay. We've got the sample selection was proportional by county, depending on the number of operators in that county, so to weight it geographically. There were 300 surveys that were sent out in the original sample. The response rate was, just over 1/3, about 37%, which I wasn't too excited about that when I saw it, but I was told that's actually a fairly good response rate for this type of a agricultural survey, and we ended up with more than 1,000 data points, 1,000 responses to work with, which was nice. And we've had a couple of papers that just came out this spring from the survey, and I'm going to be presenting results from these papers. The one on the left, I was the lead author. I'll focus more on the results from this because it's what I'm most familiar with. There's also a very interesting paper by Tong Wang, and I'm going to tie into what I think some of her more important results are to give context to the stuff that I'm presenting. I'll just point out that, you can, if you're interested in this and you want more detail, you can dive into these. The land use policy paper is open access. I think the ecological economics paper is not, but if you want it, anyone can email Tong or email me, and we'll be happy to send you a PDF of it. Okay, so like I said, I'm a landscape ecologist. I do a lot of work with geospatial data. So one of the things that I was really interested in was saying, okay, can we take these survey data, these scattered records from a variety of farm operators across the region and make maps out of them, look at some of the underlying geographic patterns. And we figured out a way to do this by developing smooth maps. Each survey record that we had was coded by the home address of the farm operator. So what we did is we used what's called a Gaussian kernel, which you see that little hat-like thing on the right, to generate smooth maps with a weighted neighborhood mean. Basically, we put a grid across this landscape, and for every point on that grid, we looked out over a 30-kilometer radius, took a mean or took some kind of a summary of all of the observations, all of the survey points that were in that circle, and then we weighted them so that ones that were closer to the center had more weight, and that weight decreased as we got further from the point that we were mapping. And basically the reason that we did this is it allows us to get come up with some fairly stable estimates based on a sufficient sample of these points. And we don't have to use arbitrary boundaries like counties or zip codes that cause a variety of problems. And so what we ended up with were a number of maps like this. So these are just maps of the mean acres per farm operator of some very broad land use types. So if you look starting on the left, farm sizes are generally smallest in the most productive part of our regions, down there in the southeast, and they get larger in general as we go north and west. And we see similar patterns in terms of the total number of cropped acres per farm. If you look at the distribution of acreage of CRP, it has kind of a funny pattern. There's this little ridge that comes down, but it tends to be a little higher in the north, a little lower in the south. And then in terms of rangeland acreage, that is an east to west gradient, where we see more rangeland in the western part of our region. So, just getting a little bit of context on the farm operations that we're looking at here. Okay, another thing that we're interested in land use decisions. So here, what we've taken is the results from another question, and we're looking at the percent of operators making various land use decisions from 2004 to 2014, and they're ranked with the ones who said yes the most, the questions that were answered yes the most up at the top, and then decreasing toward the bottom. So, the majority of these operators were growing corn or soybeans each year. A lot of them were also growing alfalfa or some other kind of hay crop. Quite a bit of adoption of no-till. About 50%, about half of them reported increasing their proportion of corn or soybean acres, a minority growing wheat each year, oil seeds, not so much, still a fairly small percentage either adopting or increasing tile drainage, and relatively few actually increasing their wheat acreage over the 10-year period of the survey. So the survey was done in 2015, and we asked them questions about their land use over the past decade, the past 10 growing seasons, so 2004 to 2014. We can also map the responses, so we can see if we look at corn and soy is more concentrated in the eastern and a little bit in the southern part of our study area. Although if we look at where the operators were who increased their corn and soy, distributed a little bit to the north, wheat is much more to the west and to the north, as with the increases in wheat. Just some other things to point out, tile drainage is still primarily concentrated right along that eastern side of the study area, whereas the no-till systems are more broadly distributed over some of the drier portion of the study area to the west. All right, so let's start get into what we're most interested in here, which is land use change. So here we're looking at the percentage of operators who made changes to their cropland acres from 2004 to 2014. And about half of the operators reported not making any changes to their total amount of cropland acres. 31% reported expanding cropland acres, and 21% reported reducing cropland acres. So, the percentage of operators expanding their cropland a little bit higher than those reducing cropland, and tending to be a little bit more concentrated here in the western part of the study area. Now let's look at some specific land use conversions. This is where it starts to get interesting. So here, again, we've got these smoothed estimates. The top row is the percent of operators. So out of all operators surveyed within the local area, what percent made the particular type of land use change? Whereas on the bottom, we're looking at the percent of farmland acres. So relative to the total or the sampled farmland acreage in the local area, what was the total acreage of change? And if you look on the left, we've got we have change in native grassland. So that tends to be concentrated to the west and the southern part of the study area, with hotspots popping up more in South Dakota than North Dakota. Tame grass is a little bit similar to native grass. And in contrast, CRP is concentrated much more in North Dakota. So CRP conversion to cropland, North Dakota, the northern parts of South Dakota. We also, there was an interest in looking at producers who were taking land out of CRP and moving it into pasture as opposed to cropland. Not so much of that particular land use conversion, tending to be concentrated in just a few areas. And then E, all the way on the right here, that's new conservation enrollment. So that's basically conservation reserve program, wetland reserve program, or any similar type of conservation program. And you can see we have some areas where there's fairly substantial enrollment going on, both in terms of numbers of landowners and acres, but they're very concentrated, and if you kind of scan from left to right, they're not really in the places where we are losing grassland from some of these other types of conversion. If we want to look at some numbers here, in terms of the percentage of landowners, it's a relative, although these percentages aren't mutually exclusive, because there are some producers who are doing more than one type of conversion. But the percentage of farm operators who are converting is actually, it's not incredibly high. We're down here 14, 15% for native and tame grass, about 25%, 24% for CRP grass to crop, and then, pretty low for grass to pasture conversion, and then about 25% with new conservation enrollment. But one of the things is, if you look at we look at mean acres per farm, there's quite a bit of variability. In particular, operators who are converting CRP grass to crop are tending to convert larger areas, whereas the conservation enrollment, the acreage tends to be relatively low, only about an average of 93 acres per farm. So if we move across here and we get to percent area, measured as percent of total farmland area, we actually have, we end up with a relatively high percentage, 3.2%, being converted to, from CRP grass to cropland, about 1% of native grass and tame grass. And if you look at that total conversion area, that comes out to just over 5%, which is considerably higher than the rates of new, more than 4 times higher than the rates of new conservation enrollment. And then just to point out that, what types of crops were being grown on these converted grasslands, it was primarily corn and soybeans. If you look from left to right, the numbers don't add up to 100% because an individual operator may be converting to corn and soybeans, or corn, soybeans, and wheat at different times for different conversions. But it's predominantly corn and soybeans, and we tend to see, we go up to North Dakota, there's definitely more conversion to wheat happening up there, but still the majority is to corn and soybeans. Now, this is what I thought was one of the more interesting results, although it's one of the things you look back on and it's fairly logical. But we found that the distribution of land use change, across farm operators was highly skewed. As I showed you in the table just a couple of slides ago, the majority of landowners, the majority of farm operators are not converting any grassland to cropland. And when we look at those, even if we look at that proportion of farm operators who are making conversions, there's a small percentage of those that's converting the most acreage. So, if we run the numbers, a total of only 5% of the operators account for 81% of converted native grass. 5% of operators account for 76% of tame grass, and those top 5% of converters account for, 2/3, 67% of converted CRP. And then down at the bottom, that's just a way to illustrate this with what are called Lorenz curves. So if the idea is that if each farm operator was contributing equally to the amount of conversion, we would expect to see a straight line. So, if we were looking at the first 50% of farm operators with conversion sorted from low to high, they would account for 50% of the acres converted. But in all of these cases, we end up with a high value of what's called the Gini coefficient. And again, basically that's just another way of crunching these numbers and saying that it's really the relatively small number of operators who are doing most of the conversion here. All right, this is something that we didn't end up putting in the paper, but I thought this was just an interesting survey result that I wanted to put out there. And the reason is, when we did the PNAS paper back in 2013, we got a lot, and again, I was probably naive in not expecting this, but we got a lot of pushback from various places claiming that, this is ridiculous. There is no grassland loss going on. There is no cropland expansion happening in the Western Corn Belt, and it's all some artifact of bad data. So one of the things that we did in the survey was we asked the producers about, just what's your perception of the land changes that are occurring, and I think it was like within a 10 or 20 mile radius of your farm operation. And basically, the majority of farm operators reported observing decreases in all grassland acres. A smaller proportion reported decreases specifically in native grassland acres. Pretty much none of them reported seeing an increase in grassland acres. And then when we look at corn and soybean acreage, pretty much all of the respondents saw an increase in corn and soybean acreage. So, and that's one of the tricks in doing these sorts of surveys. We ask multiple questions. What did you do on your own land? What do you observe happening in the landscape around you? And we find pretty congruent results here with what we see in the other survey questions and also what we observe in satellite data and other data sources. Okay, so that's kind of the what is happening. And now I'm going to delve a little bit into the why. What are the drivers of this? If, we're looking at the situation where, there's actually a small subset of operators who are doing quite a bit of, or not just quite a bit, but most of the conversion. What are their characteristics? And so what we did was fit some models using a technique called boosted regression trees. It's, getting pretty wide usage these days in ecology and biogeography. So some people here may be familiar with this. Basically, I'm not going to go into the gory details, but essentially it combines a regression tree, which is a way of fitting a model based on binary splits in terms of, say, continuous parameter values. And then it combines it with an ensemble approach called boosting that basically combines multiple trees in a way that helps to improve prediction accuracy and also reduce the risk of overfitting. And it's a nice method. It's robust to things like collinearity, outliers, and missing data, which is a big issue with these survey data sets because respondents tend to leave, for whatever reason, leave some of the questions unanswered. So we have a lot of missing data to deal with in the responses. And it's a flexible method that can fit nonlinear relationships as well as interactions. And so these are the predictor variables we looked at. And we wanted to do this, rather than on, based on some geographic unit. We wanted to stick with the farm operation as the unit of study. So essentially, we derived all of our predictor variables from various other questions that were asked in the survey. So we had, characteristics of the farm operation and the operator, the age of the operator. Was the operation primarily owned or rented? What's the income? What's the education of the operator? What's the size of the farm operation? We asked some yield questions, and we put those together to come up with a relative yield index, information about how much corn, soy, and wheat are being planted, and also some other questions related to soil characteristics, erosive soil, sandy soil, and other types of soil characteristics. So what we did was we fit models with a binary response that characterized the occurrence of different grassland conversion types on each farm operation. And so for 3 of these, where the dependent variable was operations that increased cropland acres, converted at least some CRP to cropland, and converted at least 160 acres of grassland. So, trying to identify the areas where lots of conversion was taking place. We were actually able to fit models that had reasonably good discriminative power. For tame and native grassland, we weren't able to come up with models that had sufficient discriminatory power. So we didn't explore those further. And I'm not going to go into the details of what the specific issues are there, but we're actually still in the process of looking at some other modeling approaches that we're hoping can allow us to get a better look at what specifically is happening with the tame and the native grass. So I'm going to report results for these 3 dependent variables. So if we're looking at farm operators who increase their cropland acreage, looking at these are, some of you may be familiar with these charts on the right. They're called partial dependence plots, and they're essentially the smoothed responses that we're seeing to these different predictor variables. So farm operators who increased their cropland acreage tended to be younger, they had larger farm operations, they had higher farm incomes, and they tended to rent higher proportions of their farm acreage. When we look at operators who converted CRP to cropland, they also had larger farm operations, and that was a particularly important variable. They tended to have erosive soils, higher farm income, sandy soils, and again, they were relatively young, and they tended to grow less corn and soybeans. If we look at the big converters, farm operators who converted more than 160 acres of grassland, again, large farm operations were an important driver. They tended to have, interestingly, kind of intermediate yields. But again, were relatively young, sandy soils, tended to grow more wheat, and also, interestingly, had higher education levels. Now, one of the things that is also of interest is what are the external factors that have an influence on farm operators' land use decisions? So from the from the results I just showed you, we can start to look at some farm characteristics that are more associated with cropland expansion and grassland conversion. But we can also take a step back and ask questions about the external drivers. And so again, this was another question that was asked about, what are the external factors, the issues that are having the greatest influence on farm operators' land use decisions. So if we look at this, you look at the top, the top two here that had the most respondents indicating that they had either quite a bit of impact or great impact are related to prices, so changing crop prices and changing prices in the input materials. Next, we see improvements in crop yields and development of more efficient cropping equipment. And then as we get down into the rest of these, we tend to see the majority of respondents saying that they didn't have an impact. So, pest management, crop insurance, weather, climate, labor availability, concerns over wildlife habitat. Overall, the respondents found that they were less important. And this takes us to a couple of the results that I want to report from Tong Wang's paper. Because what she did, and she wrote a very lengthy paper. It gets pretty deeply into some of the underlying economic theory. But there are, to me, there were some really interesting and important results that popped out of it. Because what she did is she actually looked at these influence responses as the dependent variable in some econometric models. And she basically asked the question, what types of farm operations and farm operators are the most sensitive to these different external influences? And she, I think, provided some results that help us to interpret the results that I came up with. So one of the things that she found was that larger farms tended to be more highly sensitive to a variety of these influences than smaller farms. So crop insurance, labor availability, pest management practices, crop yields, more efficient cropping equipment. In the graph that I just showed you, overall, those weren't considered to be, very important influences on land use decisions by the majority of farm operators. But for the operators who had larger farms, they tended to be much more sensitive to these influences. Similarly, if we look at younger operators and operators with more rented land, they were seen as they were much more sensitive to changes in crop prices and also changes in input prices. So we can look at, looking at these responses, we can start to, come up with some understanding of why larger farms may be more likely to convert grassland to cropland. In particular, they may be more influenced by the availability of crop insurance and they may be more willing to take risks on planting a crop like corn in a marginal area than a smaller farm. They may also have more resources and more access to cropping equipment to actually do the conversions. Whereas younger operators and operators who are renting land, they may be less financially secure, have more economically marginal operations, and therefore be much more interested in expanding in relationship to changing crop prices. So to try to summarize this a little bit, what did we learn from all of this that's interesting or useful? Different types of grassland loss. There are different rates, and they're concentrated in different parts of the eastern Dakotas. Where we're losing most of the CRP is not in the same area that we're losing tame grassland and native grassland. And then, in addition, conversion of native grass is indeed occurring, and it's mainly focused in central South Dakota, whereas the CRP is concentrated in northern South Dakota. We're still seeing enrollment in CRP and other conservation programs, but it's at a much slower rate than grassland conversion, and it's not happening in the same area where we see grassland conversion occurring. Looking at the operators who are converting grassland to cropland, these tend to be large farm operations with more income, younger operators with more education, farms on marginal soils and with intermediate yields, and based on some of the work that Tong Wang did, there's a suggestion that these, farms are doing this because they're more sensitive to prices and the availability of new technologies. A concern here is whether, given what we're seeing here, there's this potential for a vicious cycle of grassland loss driven by operator retirements and farm consolidation. We will inevitably over time see older operators retiring, new, younger operators coming in. We see, as families different things may be happening. You may see a younger family member coming in to operate the farm, or that farm may end up being, that land may be rented off to other operators who are increasing the size of their farm operations. So I think that's a concern. Are we going to see kind of a feedback cycle where we see, more younger operators, more farm consolidation, larger farms, reinforcing grassland loss. And then I think the last thing I wanted to bring up is this idea of the super converter, the idea that really it's a minority of farm operators that were responsible for the vast majority of grassland conversion. And of course, farm size here is a particularly important factor. Part of it is that, larger farms have more land that they can convert. But, if you look at the economics literature, there's actually quite a bit out there on, the differences, the many economic differences between larger and smaller farm operations. In particular, larger farm operations tend to depend much more on farm income, which can be from growing crops or from some other agricultural activity. And they tend to be more dependent on crop-related programs such as crop insurance, whereas on the other hand, the smaller operations are less dependent on on-farm income, and they tend to use more conservation programs than commodity programs. And, I don't really have an answer here, but I think some of this information can maybe help us to frame questions about conservation policies a little bit more clearly. How do we utilize this information? One angle that you could take would be, okay, if it's really a relatively small number of operators who are doing the majority of conversion, maybe we can target new policies or incentives and direct them, target them to this small group of operators, and they may be more effective. Another way to look at it could be to say, okay, well, maybe this small number of super converters, we can't really do, given the economic pressures that they're under and, the types of external factors that they're responding to, maybe it's not even worth trying there. Maybe we should focus on the much larger number of operators of small, maybe operators of smaller farms that may be more interested in having a more diversified land base and production base. And I'm going to end it with that, and I would be happy to entertain questions or have further discussions.
Thank you, Mike. That was a great presentation. I'm going to just open it up to those on the phone. If anybody has any follow-up questions for Mike, now's the time to raise them.
Hi, Mike. This is Max Post-Vanderberg at Northern Prairie Wildlife Research Center.
Hi.
So actually, I have 3 questions for you, but I'll just ask you one and then let other people chime in. And if nobody does, then I'll follow up if that's okay. So the dependent variables that you had in that boosted regression tree analysis and in the follow-up analysis, they looked like they were kind of making an implicit assumption that the decisions or the things that you might have anticipated as being drivers of decisions were really about maximizing financial utility or maintaining financial utility. And I wonder if you guys entertained maybe some of the potential questions that like behavioral economists might ask that are more like trying to get at the irrational side of decision making. So like, how many generations have you been farming? Are you, did you inherit a farm versus start up a new farm? To kind of look at some of those other questions that really don't have much to do with maximizing economic utility, or financial utility is what I should say.
Right, and so the short answer is no. And, I think part of that may be, the fact that I was working with six economists as opposed to 6 sociologists. I do think you raise an interesting point, and I tend to agree with you that some of those other factors may be important as well. For me, this was my first. I'd never done survey research before, and it was very I found it quite fascinating. One of the things that we did, of course, was a lot of hand-wringing in the beginning about how many questions we were going to ask and what questions we were going to ask. And I guess, a concern in putting together a survey like this is limiting the length of it.
Right.
Because apparently there's a point where, and this happens to me, people send me like online surveys, and there gets to be a point where it's like, oh, this is going to take an hour, I got to do something else. So the short answer is no. We didn't really get into those questions because it was more of an economic study than a sociological study. But I do think that would be something that would be valuable to look at, with the right people putting together, a survey and crafting it to focus on that question, those types of questions.
Cool. Thank you.
Any other questions?
Hey, Mike, this is Rick Nelson. You may have covered this, and I may have missed it. But one question that I had was, did the smaller operators, was there any move on the part of the smaller operators to become bigger operators as prices went up? Did people that were, did they suddenly start renting more land, or was there any of those kinds of things, or didn't you guys look at that?
Well, again, that's not something we weren't able to. We didn't have the right questions to tell that in the survey, and we certainly. I mean, there's certainly evidence of a proportion of farmers that are expanding their croplands, essentially expanding the size of their farm operation, expanding their cropland acreage. But the way the questions were asked, there wasn't a question in there specifically about change in total farm size over time. So no, unfortunately we didn't get that out of the survey. And again, that's kind of one of the frustrating things. I guess it's like any data collection effort. You've spent a lot of time, like I said, wringing your hands and wondering what to ask. And then as soon as you get with some of these things, as soon as you get the surveys back, you realize, okay, we should have asked it this way. I guess I would say that, my colleague David Hennessy may have some other data on this. He's also been doing a number of focus groups on various topics in eastern South Dakota and North Dakota. And that, that's kind of that's a different type of setup. The limitation of a focus group approach is that you don't get, you don't get a nice statistical sample like you do with a survey, but you can, the advantage of a focus group is you get kind of that back and forth, and you can, iterate to, towards some new questions that maybe you didn't anticipate asking at the beginning of the focus group.
Thank you.
So this is Max again. I have kind of a follow-up question to that. So one of the graphs, those Lorentz curves that you showed, those were actually kind of intriguing to me. And one of the things that kind of occurred to me is that I wonder if potentially, and this idea of the superconverters, if is maybe kind of what you might have going on here is kind of like an allometric scaling law.
Okay.
Which might be kind of interesting to investigate, because those laws kind of can help you work out, for a given amount of change in something, let's say farm size.
Yeah.
That you would expect that there could be like a threshold, right? That you cross this threshold, and it kind of like Jeff West has done some stuff with like city or the expansion of urban areas, for example, and has shown that there is kind of this allometric scaling law that the larger you get, the more area you kind of tend to need to support that larger area, but the amount that you add gets proportionally smaller and smaller and smaller, the larger and larger you get. This sounds like it might be kind of the inverse of that, and that might be kind of an interesting way or an interesting question to look at with the data that you already have on current farm size, because there might, at least at a landscape scale, it's kind of like an organism, right, or kind of like competition between species, right? They're going to be a lot of these like poor competitors, and then there are going to be a few of these really good competitors. And something like an allometric scaling law could help you maybe even predict when that's going to happen and what the consequences are of that happening.
No, I like that idea. And I know what you're talking about in terms of the allometric scaling laws, and they work for sizes like this. I guess one of the places where I've seen them is in fire ecology.
Sure.
looking at the scaling, the relative importance of small the relative frequency and importance of small versus large fires. So yeah, I think that's a really cool idea. I would have to, I think I'd have to cogitate over that more, to link it, to get the scaling law and, link it into the specific relationships and questions that are germane.
Yeah.
But that's a cool idea.
So that's really the trick, is what do you put on the X and the Y axis. But I don't know, those patterns, they just kind of look that way to me. So I could be completely wrong, though. I don't know.
Any other comments, questions?
We have some time yet, folks, if you'd like to ask more questions. Well, hearing none, I guess we will say thanks very much, Mike, for a really great presentation. I think for a lot of information there, a lot of things to think about, and I know for me it's generated some additional questions, and I'm sure for others as well. Really appreciate the fact that you took the time to put this together for us. So one last time, anybody else have a question that you'd like to ask Mike while we have him on the phone?
Well, if anyone wants to follow up later on, feel free to shoot me an email.
Excellent. And as I mentioned earlier on, we will have this recorded, and it will be available on our website in a day or so. So look for it there if you want to review. So again, Mike, thanks very much for your time today, and thanks for everybody who called in today and participated in the webinar. And with that, say good afternoon.